For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below.
We are given a system, that is what this is. Our strategy is to rewrite that system as a matrix. So let's fill in the coefficients that are missing. Here we have a 0x1 plus 1, 1, 1, 1. And this is our augmented matrix where these are our A values, these are our B values. It's really just rewriting the same thing but without the variables. Now we're told to find the solution of the system of equations. So then from here, we try to get our matrix in row echelon form by performing Gauss elimination, aka row reduction. Recall that the first step is to choose the first column that you see that's not all zeros, so that's this one. The first value that you see is going to be your pivot position. You want to make sure that whatever is in this pivot position is not 0, and it's not, so we're good. And then the goal is to kill everything below this pivot position. In other words, have everything be 0. So this is already 0, but this is not, so we have to kill this one. So I want to kill something that is in row 3. So label your rows if it's helpful. And I want to use whatever is in my pivot position to do so. So my pivot position is in row 1. Then I'm going to do plus whatever I see here is going to go here as well. And then to find out what I need to do or change here to make this a 0, I'm going to rewrite these rows below in order. So row 1 is this, row 3 is this. I treat it as an equation I'm adding, and then I ask myself, what's my goal? Well, my goal is to have this first entry be 0. So my first entry is going to be 0. Then I just focus on this column and I ask myself, what can I change of row 1? Why row 1? Because that's the row that contains my pivot position. So in other words, how can I change what's in my pivot position? That when I add this plus this, it's going to give me 0. Well, the only way that this is going to give me 0 is if this is minus 2. The question is, how can I get this to be a minus 2? Well, I can multiply this by a negative 2. But whatever I do to one entry, I have to do to the rest of them in that row, which is why this is going to end up being negative 2 times row 1. That's going to be negative 2, negative 2, negative 2, and then this is going to be negative 4. And then we add, so this is negative 2 plus 2, that's 0, just like we wanted it to be. This is going to be negative 1, this is going to be 3, and this is going to be negative 4. And then this goes here. This is going to be my new row 3. Since the only thing that I changed in my matrix is row 3, then these two rows stay the same. And the only thing that I'm changing is row 3 from this to this, because this means this is my new row 3. And then you can see that everything under your pivot position is 0. So perfect, you're done. Now you can move on to the remaining submatrix that's formed when you cross out its corresponding row and column. So that's this matrix right here. It's not this matrix because remember, we're only turning our coefficient matrix A into row echelon form. I just write it this way because it saves me time, but really what's in row echelon form is A. What we're performing the steps on is A. If we're checking conditions for row echelon form, we're only looking at coefficient matrix A, not A of B. These are our B values. We don't include these. We just basically ignore them unless we have to change their values. So let's be specific about that. So you start with your leftmost non-zero column. That's this one here. Your pivot position is at the top. You want to make sure it's not 0 inside. It's not, so we're good. You want to kill whatever's below it if it's not 0, so we have to kill this. The thing that we want to kill is in row 3. I want to use whatever's in my pivot position to do so. My pivot position is in row 2. My equation is always going to be plus, and then whatever is here, row 3. To find out what I need to change here, in order to get this to be a 0, I'm going to write down these two rows right below. I ask myself, what's my goal? My goal is for the second entry to be 0. Second entry should be 0. I focus on this column, and I ask myself, what can I change so that this plus this is going to give me 0? Oh wait, nothing, because it already does. 1 minus 1 is 0, so we changed nothing about this. We just add 0 plus 0, 0. And then negative 3. And then this matches with this. This is going to be my new row 3. Since row 3 is the only thing that I changed, these two rows stay the same. And then row 3 is now replaced with my new row 3. And now everything below my pivot position is 0, so we're good. And then we move on to our last matrix formed, which is just this. Then you're like, okay, this is my fancy matrix. Pick my leftmost non-zero column. Oh wait, it's 0, so then you're just done. Because your pivot cannot be a 0, so therefore you don't have a pivot in this column. And so you're just done. You would, whoops, that's supposed to be a 1, my bad. But yeah, so you only ever had 2 pivots, this one and this one. You could have also just checked if you were in row echelon form by checking ZO. So are all 0 rows at the bottom? Remember, when we check the conditions, we're only checking this matrix here, the coefficient matrix A, not this whole thing. So in the coefficient matrix A, are all 0 rows at the bottom? Yes, we have 0, it's at the bottom. Does it pass a staircase hack? Well, these are the leading entries. If we do staircase hack, the height of each step is 1, we're good. Are all entries below the leading entry 0? These are the leading entries. Are the entries below 0? Yes, yes, yes. So it passes so it is in row echelon form, and therefore we see that 0 is equal to -3. So if we rewrite this back into a system, we would get 0, 0 equals -3, and then these would be attached to variables x1, x2, and x3, and that's just essentially 0. So that's why I just go automatically to that. And I know that that's not true. 0 is not equal to -3, so therefore there is no solution to the system, meaning that these equations do not intersect. So instead of going into reduced row echelon form of A to find the solutions, we can just stop here because there aren't any solutions. So there's no point in reducing it further to get solutions if there aren't any. So that's it for this video. I'll see you in the next.